Well, hi, good morning. Thanks so much for joining me here in my shop. Today's August 11th. Yesterday I took steps to try to resolve the issue with the burned coil, and unfortunately it's still not resolved. Even though I had the radio operating, it appeared as if the earlier stages are not functioning. And the way I determined that was by touching these grid caps here. There's one more over here on an audio tube. So this tube I'm pointing at now is the one that starts the audio process right here, the detector tube. When I touch that cap, out of the speaker came a hum. Well, that indicates to me that beyond this tube things are working. But when I touch these, I should have gotten the same kind of response, or something anyway. Something pretty dramatic should have happened. Nothing happened. So I think the next step is to do some tube testing and go through them all. Now I do actually, right on my bench, I happen to have some Rogers replacement tubes. I have a box of these too, but I don't know their condition any more than I know the condition of these. So if we find one of these is bad, we could opt to replace it with a more original Rogers type if I have one. Or I think the smarter thing would be to put in this type of tube. So the original here was a was a 6A7 externally coated tube. This is a 6A8 metal tube, which is a suitable replacement. And it has a grid cap on it. Of course, it has to have a grid cap on it to work in the radio. Okay, great. Right, tube testing. Okay, let me get that set up. Well, about 15 minutes has gone by here while I study up on these tubes. Now, I have come across these before, 2X3s, and I know they're very rare. These were only used in Rogers radios, similar to the one I have on my bench. That's a Canadian thing, only in Canada, and maybe some Rogers radios were exported to the United States, so there might be a few radios running around with these. You know, most of the time, like this is half a tube, right? It only has one side, a little hard to see in the image here. The other side is nothing. So you have to have two of these. And the suggestion I read was that was Rogers just making you buy more tubes and have more tubes in their radio so they can say, you know, it's a 6-tube set. This can be replaced by a 5Y3, which is a double section tube, but the pin-out arrangement is completely different. You have to rewire the radio to support using a 5Y3, which is a much more available tube. I have quite a few of those. I have one 2X3 somewhere in my collection. It's not clear where it is, which means it might take me a long time to find it. My note says 2X3 in a 6F6 box. Well, why did I leave it like that? So, big question here. What do you do about this? Might as well go ahead and test it, right? Well, guess what? This tube is scarce enough and rare enough and odd enough that it's not listed for this tube tester. At least I haven't found a listing yet, or any tube tester. Now there is another one that they say is a direct replacement made by another manufacturer, and it's a 2W3. Now you know what? There's one sitting right here in my tube tester listing. 2W3. Now look into this a little further and see if a 2W3, I can set this up for 2W3 and then put this in. I am suspicious one of these two is not working because I only saw one filament heating on one of them. The other tube, the filament didn't seem to heat, but I didn't make a careful observation of that. Well, that's a tough spot. If these tubes are defective, it's a tough go to get replacements on that. Okay, I'm going to study up a little more into 2W3 and see if it isn't a really direct replacement here. If I can find that out, that is. Good luck to me. Okay, so I found a couple of references, including a very official reference that says a 2W3 is a direct replacement for this 2X3. So I've set this up for a 2W3. Let's put it on. Double check here. 2W3, 2.5 volts filament, HR for the filament connections. Then I've got a mistake here. 04000 04000. So I read my chart wrong here. That's why I double check these things. 030 on the English setting. We have this switch to English, so it's basically a replace or good type measurement. There's no transconductance to measure in this tube. Okay, we're going to stick it in and see what happens here. I don't think anything bad can happen right off the bat. I'm looking to see if the heater heats. Now this is the one I'm pretty sure I saw the heater heating. I saw the heater heating. I don't see it now. Ah, you gotta wonder. You gotta wonder if this is really the right thing to do. 2W3. Absolutely nothing here. Carry on with the test, just in case the heater is so weak I can't see it. Looking for shorts right now, so I'm watching this light to see if it stays on at any point. It does not. P3 for a rectifier test. What did this do? This went down and then up. What's with that? So this is showing the tube to be functional, although weak. Yeah, it's going down as I hold the button, which usually indicates a worn out cathode or worn out heater surface here. I don't see any hint of heating in this tube, but it's getting warm. I like these things to, come back with some level of certainty in them. Let's get this other tube over here. Interestingly enough, this other tube, it's not a Rogers tube. General Electric. Tell me this one's not going to have a number on it. Oh my gosh. Oh yeah, it's right there. 2X3. It says 2X3 on it. And made by General Electric. Well, that's interesting. Okay, 2X3, same as 2W3, and she goes. See, it has a large glass bulb on it because the thinking is it's going to be hot. It's going to run hot, so I put a larger glass bulb on it. Okay, short check. Okay, we don't see any shorts in it. P3 did that same thing. It went down and then up, but look at how far up it came. It hardly came up at all. Have I not got 2.5 volts coming on the filament? Why both of them test? This one's really, look at this. Maybe it's this button here that's doing the up and down thing. Well, that's an extremely low reading. I don't feel any heat. I'm going to leave it in there for a little bit. I'm not convinced. Oh, I can see the heater. I can see it. Oh, this is the one with the big burned area here. Yeah, it's warming up. I can feel it. So this is it. So you have two rectifier tubes here, neither of which are very good. And certainly this would explain the failure of the radio to thrive and work well yesterday. This could be the explanation. You have to solve this now. This is the next, well, of the things we know, this is the next kind of serious problem in the chain here. What am I so along with the possibility, I'm just untangling a cord here, along with the possibility that we could find 2X3 tubes. We could buy them perhaps, but they're rare. Find 2W tubes if they really are direct replacements, but they are also very rare. The problem here is the rectifier tubes have a short life. Rectifier tubes work hard in a radio like this. They're designed that way. To make these tubes more rugged would make them too expensive. So the alternative is to make them in a similar way to all tubes and just accept the shorter life. So these tubes, the rectifier tubes, usually there's only one in a radio. They get replaced quite regularly during the life of the radio. Same thing with the output tube that drives the speaker, which would be this one. So there is another alternative here, and that is to rewire the socket and put in a more typical tube, a 5Y3. There is yet another option here, and that is to put diodes in. To replace these with silicon diodes. All these have problems with them. The diode thing sounds simple, but it's actually not. It leads to a couple other problems that have to be resolved with voltage levels. But the diode is an attractive solution because there's no cost. The diodes are, they cost a dime. They don't cost anything. So there's a possibility there. Okay, let's just carry on. We'll see what we find out with this one. This is the audio output tube. This was the 6K6. Yep. This also is a kind of tube that tends to wear out. Here, I'll just let you watch me set the whole machine up here. 6K6. So I'll roll this up. 6, I'm looking over here. You might not be able to read this little print. 6K. 6K. Went way too far. JJKL. 6K6 right there. 6.3 filament voltage. JR. 5347 with a 0. 5347 with a 0. I don't have to double check this because you're watching it, and so you're making sure I don't make a mistake here. 34. The bias control, 67 if we care to read this in English. What I mean by that is there's a meter setting. This is the meter control. There's a meter setting called English right there. English. Replace or good. Replace or good. So you can run this meter so you're just paying attention to the replace or good. Or you can make an actual measurement. If you put it here, you're now on a scale. The 3,000 scale, 6,000, and 15,000 scale. I don't know if I've ever been up there. I usually like to take the actual reading. So I'll leave this on the 3,000 scale. And now we will do the double checking. 6.3 JR, yeah, even though you're watching and making sure I do this right. 5347, 5347. Didn't hear a word from you, so I'm talking to you, the person who's viewing this video. 67, all ready to go. Okay, I have a lot of these 6K6s, so no problem if this is a dud. Okay, I can see the heater coming on here. Give it a moment. The heater has to heat up, and then the heater is inside of a metal sleeve called the cathode, and it has to heat the cathode up. And the cathode is where the action is, where the electrons are coming off, not the heater. The heater's inside, but it takes time for the heater to heat up and then the heater to heat the cathode. But for sure it's there now. So this light flashes, that's fine. Those are just charges. It's not a problem. If the light stays on, then there's a short in the tube, and that's the end of the test. So this tube, 6K6, should read, if it comes up to 1010, if it's below 1010, which is right here, then it's a throwaway according to this. And a good tube should read 16. So 16 just up in this area here. Drum roll. Right up here. So this 6K6 is a very good output tube. Well, that was just great. Okay, now we're going to go to the tube that's electrically just ahead of that in the chain of things in the radio. This is the detector tube. Now this tube, you basically feed in the radio signal and the audio signal comes out. Now that's a very simplistic description of it. So we're going to do this one, 6Q7. 6Q7. I'm just going to keep it rolling here. PQRST. Menno PQRQ. I get turned around. 6Q7, just absolutely sure I know what I'm doing. That's tough. That's a tough one. 6.3. There's 2 tests for this tube. Maybe 3 tests. Should be 3 tests for this tube. 6.3 JR 0307 with a 2. 03072. 17 40. If we don't use the English setting here, then this control actually doesn't do anything. 40. Press B4. Grid cap. Okay, we gotta put on it. Grid cap here. Oh, that's where that is. Stuff falls down in behind, but not the thing I'm after. Where's the grid cap? Lead. Son of a gun, it's missing. Oh. Okay, gotta stop for a minute and find something that's missing. I got no idea where it is. Didn't want to look all over my house for those grid caps, and so I got a different tube tester here. All my tube testers are highly reliable from experience and comparison things I've done to find out if they really do reveal the truth, and they do. This one's just hard to see the meter on the camera, but let's see if I can make it show up. Okay, so this guy works just a little bit differently. 6Q7, 6.3 volts, filament, signal level 1, bias 23 L. There's a H and L, high and low. 27300, 27300, 0610, 0610. More dials to turn on this tester. Sensitivity 48. Plate setting is A. Oh, I think my. So when you're working on these things, and they have the roll chart here with the numbers on it. While you're working, the roll chart can kind of roll just a little bit. Sometimes you end up. Sometimes I make mistakes based on that. Let's just go through it again. 23L 27300 30 F. Yeah, you see this. A is from a different line on this chart. That's better. Grid cap. Well, I've got the grid cap right here. We're ready to go. Switch it on. What did I do with the tube? Here it is. Double check. 6Q7. 6Q7. 6.3. We are ready. Okay, we'll put it in. Put it in one of these sockets. Which socket is it? I haven't used this for a little while. Wait a minute. This can't be that complicated. And we'll put the grid cap on. There we go. Okay, now we're ready. Like the other tester, this one does a short check first. Let me just see what I can do about the lights here. You know, I really gonna have a hard time making this visible. Jeepers creepers. Looks like if I just shade it a bit, you can see it. Okay, carrying on. Short check. In this case, there's no flashing light. It actually comes up on the meter. I'm watching the meter. Expecting it. If it's a problem, it will come way up. You can't even see the pointer. It's going nowhere. There's no short in this tube. We are now ready to check a GM test, and the number is 780. So 780 is right around here. Wow, it's way above. Okay, now there's two more. This is a 3-part tube. It's got 2 more parts in it. It's got a diode in it. So we'll do the diode test. I'm not sure in this tester I can leave the tube in while I'm changing these numbers. The other tester you can, but this one I'm not sure. 2703P. 2703P. 0610, 0610, 48, trying to not make a mistake. Oh, this control was in the wrong place on the last test. Ooh, that's why we got such a high meter reading. We'll have to go back and repeat it. I made a mistake on it. A, this time we're over on plate A. P1, P2. So it's plate 1, plate 2. There's 2 tests done, and the tests are this guy. I flip this button. A good. No, it's not that guy. Let's put this back in. And wrong. It's got to come up above this. There's a little word here you can't see. My timer's going off. Have a look at that scale. I gotta run. Okay, tube tester, you just wait. Just wait here. Okay, hopefully you can see the dial a little bit better here. Now, what was I doing? I was doing the 6Q7, the diode side, 2703P, 2703P, 0610. 48. Get this right now. 48. Oh, it's there. Already set. A. Okay, we're ready. P1, P2. So we're testing now are the diodes that are inside this tube, and all I got to do is come up above where my finger is here. Still can't quite see it, but there's a mark on the scale here. It says diodes okay above this line. Rectifiers and diodes. Oh! There we go. Yeah, tube tester trouble. Okay, so that one's okay. Now there's another one. Just flip this switch and we'll do the other one. And it's good too. Okay, so that part of the tube's good. We got to go back and test the other part. Okay. Go back, signal level 1, 23, low, correct, 27300, 27300, that's the same, 30 on the sensitivity. This is the one I got wrong, the sensitivity way up, so the meter was reading way high. F, don't get that wrong, that's the plate setting. Grid cap is on. Just give it another minute or so. Warm back up. Okay, this time with the correct meter sensitivity setting, and we're going for 780, so around here. Well, that's a more realistic reading. So it's at the low end of its function, but it's working. The main thing we're doing right now is making sure these tubes are working at least good enough to do something in the radio. They don't have to be in perfect shape, but they have to be working. Okay, so that guy's done. So now what's left are these 2 tubes. So this is the first tube in the radio. The signal comes almost straight from the antenna to the grid of this tube. This is a complicated tube, probably has a number of tests. 6A8. Come on back around here. terrible lighting situation. 6A8. Okay, here we go. 6. 6A. A little hard for me to see it here. 6A8. There it is. 6A8. A 6.3 volt filament. Signal level is set to 1. Bias is set to 20L. 27345. 27345. 4610. 4610. This time, because you watched, I will accept that. If I made a mistake, you tap me on the shoulder and tell me. See? So we're not going to double check these. Grid cap, whole tube, all at once. There you go. Grid cap on. You know, by having the grid connection at the top of the tube, that means the grid circuit and its lead wire in that is quite remote from the plate. And the plate lead wires, which of course are the bottom pins, one of the bottom pins, and separating the grid lead from the plate lead is important in a radio because the grid is very sensitive and the plate is very strong. The signal on them. Okay, a little bit of filler there before I do the leak test. No leaks. Very good. Let's look again. 6A8, 750, similar to the other tube number wise. So 750 right about there. Here we go. Ooh, that's a weak one. That's a weak one for sure. See, can you see where the pointer's coming? It's just not. It's just. You really have to use two cameras to do this really well. Okay, so it's hard to see the scale. That's 1,000 I'm pointing at. 780 is you know, halfway between 1,000 and 500, so somewhere around here. See, we're right around 500. What I like to do in these cases is, wow, this is just a terrible lighting arrangement, isn't it? Hey, shadow of the camera. Okay. I like to wiggle the meter sensitivity control because these aren't precise anymore. This is an old tester. And I want to see how much difference it makes. Not much. And the bias, very little difference. So even if these controls or settings aren't exactly right, we're still getting a valid reading on here. So that's a weak one. That's a very weak tube. It's well below the reject point. It's half the reject point. So we're going to put it back in for now. But I think that tube's a real target for replacement. What we're going to get at next, and go for the old Rogers tube here. This could be the only original tube in this radio. Yeah, I guess the Rogers Corporation thought they really had the cat by the tail here. They came up with this technique of putting a metallized coating on the outside of the tube, and you no longer needed to slide this metal can. Like a lot of these old radios have metal cans coming over top of the tubes, and you know, that's money, that's expense. So here they just blasted it right on the side. You can actually see the little connection right here that's trying to connect this material, which is conductive, to one of the pins underneath. But it wasn't long after this that this came out, these metal tubes, and this is a superior technique from this. So that means Rogers made these tubes for a number of years. It says licensed by Thermionics Limited. That's interesting. Is it not Rogers making these tubes? Well, maybe they had a contract with another company. Thermionics Limited. That's electronics based on heat. Heat. You know, tubes are really, really cool things that we work with all the time when you're working with these old radios and that. You think, it's an old tube, why not have a cool transistor? Transistors are boring as crap compared to a tube. What's going on in a tube? I mean, you're fooling around with particle physics when you use the tube. I mean, you are with solid state stuff too, but not like this. You're blasting particles through space between, grids or plate or something like that. Physics. Hey. Okay, enough yapping about it. Let's test it. Make sure it's the right tube first. So most of Rogers tubes, they either are here or they've written it right up around the top here. Okay, it's up around the top. It's very hard to see. Let's try this. Provided I can dig this camera out. Well, it's so dusty, you can hardly even tell there's any writing on the top there. And this camera's not doing it justice at all. I have no reason to think this is the wrong tube. I already verified that right at the start. This was the right tube. Okay, I have to find my magnifier. Where's my magnifier gone? Okay, you can see I've got a camera staring at the top. I couldn't find my magnifier, my glorious little hand magnifier that I depend so much on. So here's what we see. If you look at the lower left, around like 8 o'clock, 8 o'clock on a clock, you see 6K7 written there. So no doubt 6K7M. M is the Rogers metal. Looks like they must have, maybe this white material was to adhere to the glass, and then the black material is the conductive material that went on top. I don't know. You can see right inside the tube though. See how the screen is not even, or whatever that is, that's in there. It's not even perfectly circular. It's kind of bent up here at the top, inside the tube. Okay, not that that really means much, but we have the correct tube. So let's give it the test. And we'll find out. I'm going to guess this tube is a dud. That is my guess. And I'm going to get rid of that shadow by doing this. So, excellent. Okay. Sort of okay. 6K7. 6K7. These are old tubes. I hope it's in here. 6K7, there it is. Of course the 6K7's in here. So this is not a special Rogers tube number. There's lots of 6K7s out there. 6.3. 2, a little more signal on it. 33L, 33L, 17342, 17342, 0610, 0610, 13. Oh, 43. 43. Well, that's a big difference, isn't it? 1343. 43 C. Okay, it's on C. Grid cap. Heptode. It's a heptode tube. Okay, we're all set. Here we go. You can see the pilot light flicker slightly as I plugged it in. That indicates the heater is drawing current. That's a very good sign. Yeah, sometimes the indicator light is an important test feature in these things, because when you plug a tube in, the filament is cold, so it draws a lot of current just for a fraction of a second, and during that time it makes it dip, just like the lights in your house will dip if you turn on your vacuum cleaner. That kind of thing. Okay, looking for leaks now. And we're watching this pointer, hoping it doesn't rise up. No, it's working completely normal. We are good to go for the test. 6K7, So this should read about just over 1,000. So there's the 1,000 mark where my finger is. We should be just over it. 17342. 17342. It's a rare tube, and I don't want to do any harm to it. We're good. We're good. Here we go. She's good. So 1070 is the reject point. And where we are here is that we're actually around 800. So we're a little low on it. But remember, one of the reasons you bought a tube tester is to sell tubes. And if the thing tested every tube good, you wouldn't sell many. You wouldn't sell many, would you? This reject point number is a judgment made by the manufacturers of the equipment, and based on information gained from the manufacturers of the tube. These are all kind of standard things. Maybe not all of them. Okay, so the story is, we really can't explain the failure of the radio to operate based on tubes. So what I mean by that is it didn't seem to receive anything. I didn't really attempt to receive anything. I just gave it the finger test here and got basically nothing from it. So we're back to the two rectifier tubes. I can't even remember the test results now. I've been distracted so many times this morning. They worked. They were working. So, first tube in the radio, second tube in the radio, third tube in the radio, and fourth tube. But you can't see what I'm pointing at. I'm pointing at this tube and this tube. So the signal's progressing through the radio like this, basically. Not these. These are power supply tubes. They're not part of the radio, really. Not the radio part of the radio. So touch this, here, nothing. Touch this, here, nothing. Touch this, lots comes out. I think we need to repeat that test. And another thing I didn't do yesterday is I didn't change bands and test the other band. I didn't put an antenna on the radio. Let's do all those. Did I put an antenna on? Let's do all those things and see what happens at this point. Okay, so let's hook up an antenna here to it. Yeah, I think I did this last time, didn't I? This is an outdoor antenna, and I figured out counterclockwise was broadcast, and that's where this is. And the tone control has the switch on it. Volume control is here. This is still really terrible to turn. Didn't loosen up. Turn up a little bit. I also have a replacement for the 6A8 right here. So one of my stock and number 4 actually. I've got like, I don't know, 20 of these. All tested good. Various shades of good. This one's very good. We'll try it with the original, then we'll swap tubes and see what happens. So broadcast band, defective coil in place. Who knows what's going to happen. Run the radio, switch the band. Can we pick up shortwave at this time of day? Well, we're going to find out. I'm just going to strain really far. This here. That's the antenna lead. Okay, I'm going to clean up my bench a little bit because I got too many wires from evening projects that I'm doing. Just don't like too much stuff around on the bench when I'm going to start something up. Old sock. Okay, I think that's pretty good. We're plugged in. We're set for high voltage here. Let's just drop this down to start with because I'm chicken. I'm a chicken. Here we go. Okay, do we get enough to make this work? Yep. 60 volts. 10 watts. give it a little bit of time here. I don't think there's a problem. I could have tested these other Rogers coded tubes here, type M tubes. Okay, let's go up in voltage. I'm going up. I hear the radio now. So we're at 80 volts on the radio, and it's making sound. Now, is the volume affected? No. Volume not affected. We can't see the coil. I'm assuming previously I tested it and the coil was good. That was not burning. Is this radio operating in this band? So we do the finger test on the antenna. No noise change. We take the antenna off. Nothing. Oh. Now that could happen if I did this. Yeah. So that little static doesn't mean anything. There's no throughput on the radio. I think on the broadcast band, it's just nothing getting through. Nothing at all. We're going to switch bands, and again, I wish I put a knob on, but I haven't. So we're going to switch bands with this. We're going to go this way. Oh, volume. No. That's right down to nothing, so I'm going to turn it up a little bit. Okay, this could be noisy. Make a band change, and it was this way. Nope, it's the other way. That was it. I got to put a knob on there because I can't tell what I'm doing. I cannot tell. Okay, now I'm going to double check the cabinet here. Short wave would be, that's short wave. Now I don't hear any clicking in the radio. So there just can't be anything, nothing's changing. So there's nothing getting through, but if it could, it would come out the speaker. The audio side of things being okay. Now, another thing we can do here while it's operating is we can examine these two tubes and see if there's any glow coming out of them. Funny thing is, in the camera, the glow, I'll take that back. So, you can see the glow here on this tube. This one's metal, so you can't see anything. This one's metal, you can't see anything. You can see the glow on this tube. Now, interestingly enough, the glow on this, no, that's a reflection. That's not a glow, that's a reflection. So do I see a glow in there? Faintly, you can faintly see it there. And the other two? It's under a bunch of dirt. There it is. So they're all there. So, and we don't know about AM versus shortwave because they both sound the same. And neither one is making it through. Okay, well I think that's it for today. Yeah, I think I'll call it quits here today. It's another fantastic day outside. I should not be in my shop at all. And I still have the video to work on and the like. So, thanks a lot for watching. I'll think about this for the rest of today, and tomorrow I'll figure out what the next step might be with this radio. We don't know if the AM coil is working. We're unable to use the radio to prove it one way or another because there appears to be other trouble in the radio. And I didn't bother changing this tube. Okay, take all that back. We're going to hang on a little longer. So touching this, even if this tube is dead, touching this should have caused a response. So changing this tube is not going to do anything. Yep, that's the end of that. That's the end for today. Yeah, absolutely end. So thanks a lot for watching, and see you on tomorrow. See you tomorrow.